All right. So first we need to find these corner points, right? Because we're given these numbers, so it's the most convenient to go from there. Um, uh, so we have 2% cross slope. So we know that these has to go 2% down. And so that because of that, we assume that this is also 2% down. And with 2%, and I believe this is 5 feet long,
Mm-hmm.
with that, you will find the DE to be zero point 0.1. So this one is lower, so you'll get 72.3 here. And this one's higher, so 65.5.
Mm-hmm.
Is that what you're getting?
Yeah.
Okay, so good. Now we need to find these points. So we don't know the slope here. So that's what we want to find out. First of all, I think we need to use these 2 points as your DE for the overall slope
Okay.
because we're going kind of like that, right?
Mm-hmm.
So it's best to just use the inner length of these and then add them up as your L. I don't know what those lengths are. Did you measure that out?
Yeah, the that one is 30 feet
Okay.
and then the other one is 20 feet.
Okay. So 30, 20,
Yeah.
30. And then if you add them up, your L becomes 80
Yeah.
and your DE is 6 point, I want to say 8. Yeah. Yeah. Okay. So you plug that into your slope formula, right? And you
Mm-hmm.
will get your 6.8 over 80.
Yeah.
And you get point, wait, is it 6.8? No, never mind. Because this is going down. So this is not 65.5. This is 65.7
Oh.
because the slope is going down this way and this one is lower. And so this one has to be higher. So we add
Oh, okay.
1.1 there. Okay. So this one is 6.6 as your DE. So 6.6 here. And you get 8.25 as your general slope.
Yeah.
So you label that 8.25 and 8.25. Okay, so now you're able to find these corners because we have the slope.
Okay.
And with that, we simply plug them in into slope formula. So we have our slope 0.0825 equals our DE is what we want to find, and our L is 30. So you multiply both sides by 30.0825 by 30, you get 2.475 DE. So then you just, to find these corners, you just, this is going down, so you subtract them from the corner points.
Um,
So 72.4 minus 2.475 equals 69.93. And we don't really need to do a calculation for the bottom one because we know that the DE between these two is zero point 0.1
mhm.
because we did that calculation already. So this is simply 69.83. And this is going down because cross slope 2%. And we know that there's no horizontal slope going on. So the other corner is the same as this side. And you just um, take them over. And you do the same process for the rest of it. So same thing here. You use your L here, 20, and same slope here. So your 0.0825 equals your DE over 20. So your 20 times 0.0825, it will give you 1.65. DE equals 1.65, and you just take one of those numbers and subtract 1.65 from it. 69.83 minus 1.65, you get 68.18. And this is also having a crossover down that way. And you do the same because there's no horizontal slope.
Mm-hmm.
You do that. And then 2%, we know the difference in elevation is 0.1 because we did the calculation already. So that will give us 68.08 here, and as well as this side, 68.08. And to verify if we did these correctly, we can try to find this point. It's given, but we can try to verify. So 0.0825 equals, well, we actually did the same calculation, DE over 30. And that gives us 2.475, so 68.08 minus 2.475 will give you 65.6, and that's that.
Mhm.
So this one worked out, and that's all for this question.
Yes.
Is there anything that is unclear or you still need clarification on?
For me, everything's good.
Okay. And any question on this one?
Oh, I haven't started that one. Do you think you could show us and how to do it?
Okay, so this one, you want to figure out all the steps first, right? And with that, we need to look at the prompt. It says 2 sets of 5 risers. So we will have to set that up, and every step is 12 inches or 1 feet. So you kind of measure 1 feet apart, right? Do something like that. 1, 2, 3, 4, 5. So that's 5 steps. And then we have a landing of 5 feet. So do 5 feet, 5 feet, and then another set, 1, 2, 3, 4, and 5. So that's our steps drawn out. You guys will need to measure it, but that's pretty much how the steps will look like. And you're given with the TOS of 145 here. So we need to find the steps. Over here, it will be, every step is 6 inches. So half a foot. So over here it will be 144.5, 144, 143.5, 143. And then the bottom TOS here, and we need to find the bottom. So 142.5 is your bottom of step here. It's important because that's the top of this ramp, so we need that number. And
I have
then
a question.
yeah, go ahead.
I thought the risers are 6 inches, but the threads are 12, aren't they? 12
Yeah,
inches?
so 12, that means it's 1 foot apart.
Yeah.
So these distance is 1 foot.
Oh, okay.
But the elevation of these point elevations are these, like they're half a foot apart each.
Oh, okay.
So yeah. So if you, where are we? We need to find these spot elevations as well. So over here, we need to find out what this ramp is. Does it have slope on landing is 2%? So this thing is 2%. So with 2% and 5 foot, we can do the calculation and find out that the DE is 0.1. And so we subtract that from the bottom of stairs on the top and towards here, so we get our 142.4 as top of stair. And then we just continue with that. 141.9 here, 141.4, 140.9, what is it, 40.4, and then our bottom is 139.9. TOS and BOS. Sometimes the idea of top of step and bottom of step is a little bit confusing, so let me know if you guys need clarification on that.
Can you explain me again how, because you said it was 5 sets
Yeah.
or 5 steps, and I see 4.
Okay, so it looks like 4, right? But if you're on the landing and you're walking up there, so the first step you'll take is this 1, and then 2, and then 3, and then 4, and then 5, right? So it's actually 5 steps here. So if I draw that in section, it will look like 1, 2, 3, and 4, and that. So if you're looking up from the top, it looks like there's 4 steps, but realistically, this is also one more step right here. So
Yes.
that become your 5 steps. And this is
Then you
our
said-
DOS, and this is our BOS. And this is why we need to find that BOS. It's in order to find that slope for the ramp.
Right, and you said that every step is 1 feet apart, and then the large one is going to be 5, right? 5 feet.
Okay, so the ramp is 5 feet apart. Every step over here is 1 feet apart. The height of them is half a foot, because we are given the information that the riser are 6 inches. Riser is the difference in elevation for the stairs, and the thread is the length of it. So 6 inches is half a foot, and we do the conversion that gave us 0.5 foot over here. Each of the step is 0.5, and then the length of it is 1 foot. Okay. So, okay, with that, let's continue. I know the whole length is 20 feet because I just know it. You probably need to measure it, but say this is 1 and 1, so 4 and plus 5 and plus 1, 1, 1, 1, so 4 more. That will be 13. So we have 7 feet left on the rest of the landing. And we're using also 2% because that's the requirement. So with that, we are able to find these 2 points. So 2%, right? And our length is 7, so equals our DE over 7, and multiply both sides, 0.14. So our DE is 0.14. You subtract that from 139.9, and that gives us 139.76. So, okay, so that's all of our stairs figured out. And from here, we need to do the cheek wall or retaining wall. And realistically, that wall would extend all the way out there and then up here, and then probably a bit more here. But we're not given any information on the top, so usually I stop right here. But keep in mind that realistically, that wall will have to extend up there. But for this question, this is fine. Okay, so now we need to find all the wall elevations. So let's do it on the left side. And we know that top of wall should be 2.5 feet higher than top of stair or bottom stair. So over here we have 145 as our TOS here. So the top of wall would just be plus 2.5 on top of that. So 147.5 is our TOW. And you want to do that for the rest of them, like the important points from here. That will be bottom of stair will be 145 TOW. We add on top from the bottom because we're going from the landing. So, and then over here, it's the top of stair 144.9 TOW. And then over here, 142.4. And then the rest of it, we use this number. So 142.26. And that's all for this question.
Why do we need to know the max side slope? From the instructions,
which side slope?
it gives us the maximum side slope on land. Why do we need to know that for like the question?
I don't know why they give you that information, but you don't really need to know that because you have the retaining wall. So with that, you don't have to regrade anything.
Okay.
If anything, it will be this thing hits here and then continue to this 145 and then go to this 145 and then do that, and then connect back out. So that's your contour that's on the stair. You can do all of that, but I don't think you're required to do that. So yeah.
Okay.
You said that the top of the wall is gonna be the height plus 1.5, right?
The top of wall, you have to look at the problem. It tells you that the top of wall is 2.5 feet higher than TOS. Top of stair and bottom of stair. It's using a different terminology, but it's the same thing. Top of stair and bottom stair. So over here, it's just gonna be 2.5 feet higher than that. So therefore we got
Right.
147.5 here.
And on the bottom, the last stair, you did 142.26, and that was the top of the stair. And for the BS, how do you find that out?
142.26 is from this connection at the sidewalk. So this is the lowest point of our whole problem. And we also need a retaining wall here. So we add 2.5 on top of that to get that.
Oh, I see. Okay, got it.
Okay,
Thank you.
any other questions? Did you guys start doing page 2 yet?
Is
No.
it okay if we move to the next page?
Yeah, page 2. It's a combination of what you have done on page 1. So you're just combining all you've done previously and try to apply it here. So you want to look at, you want to find all the points. Everything is almost measured out for you, so you don't have to really measure. So that's an easier part. And by looking at this, we know that there's no cross slope this way because these two numbers are the same. So therefore, we can assume that this one is going to be the same as this one. So 94.84. And then here we have a 4% slope going that way. So we take that 4% and multiply by 9 feet, and that gives us 0.36 as DE. And we subtract that from this number, so it gives us 94.32. 94.32. Okay, and from there we have a landing, which if you look at the requirement, landing minimum 2% cross slope. So we know that we need a 2% cross slope on the 88 ramp here. Therefore, the landing serves a purpose to connect this ramp to the walkway. So therefore, we need to connect it where we're gonna use that same 2% here, so that it will connect. And 2% with 6 feet, do the calculation, we get 1.12. So that's 94.2. 94.2. And then we have that 2%. And we need to find the bottom numbers before we do anything in the middle. Okay, so we know that this contour is crossing right on top of that point, so we can assume that that point is 92. But you can always do the calculation. So take that DE, which is, what is it, 0.16, and then you solve for the slope. So we have the length of 8 feet with that width. So divide that by 8, you get 2%. So this existing walk slope is 2%. And that we use that 2% to find this number if we want to verify. There's 9 feet across that. 9 feet with 2%, we get 0.18. So you subtract that from 92.18 and you get 92. And then over here, we got 6 feet across on this side. So with that, you multiply 6 feet with our 0.02 slope, and we get 0.12. So subtract that from 92, and you got 91.88. And yeah, and we have that cross slope here, and this one is the same because cross slope is going that way. This one is also the same. And from the problem, we know that the landing at the bottom of the ramp is 5 feet long. So we know this is 5 feet long. And then we know the whole length of that ramp is 35. And we want to find out what's the slope in this distance. So that distance is just 35, subtract 5 feet because we want to take that out of our calculation. So 30 feet is up here. And our DE is 94.32 minus 92. So that gives us 2.32. And that over 30 will give us our slope on the ramp. Which is 7.73. So we got the slope there. And over here, we need 2 risers minimum. So 1 riser is 15 inches. So that's 1.25 feet. Just draw that. We need 2 risers. And let's label these. The riser is 5 inches. So we need to figure out how much is that in feet. So 5 inches over 12, that gives us 0.42. So this first point of that stair, the top of stair over there is 94.42. And then over here, 94. TOS. And then we need the bottom of stair because that's important. So that would be subtract another 0.42, 93.58 BOS.
And do you say that those are 1 feet away as well?
They are, you have to look at the problem. It says thread is 15 inches. So that's the distance away.
I see.
The steps are not always going to be the same 1 feet all the time. And in this case, it's 15 inches, which is 1.25 feet away. So if you add that together, we got 30 inches here, which equals 2.5 feet. And that will come useful when we're solving for the slope down here. So we got all the information up there. We got the BOS, which is going to be our top of our walkway. So to find out the DE, 93.58 subtract 92.34, so it's 1.24. That's our DE. And we need the length of the remaining walkway, so 35 subtract 2.5. So our length is 32.5, and you do the calculation to find slope. 1.24 over 32.5 gives us about 3.8%. 3.82 to be accurate. So that's our slope there. And let's verify if that's okay. Walk slope, maximum 5%, minimum 2%. So that's within that. So it's okay. And the other side, handicap ramp, maximum slope 8.3, minimum 2%. That's 7.73%. So that's okay as well. So what's left is just regrading the contour. So you guys know how to find out the whole number of points along these things, right? It's gonna be the same as how you do the previous assignment. You want to find where 94 is. So I'm just gonna guesstimate it's probably gonna be here and here, because that is a bit longer and that's a bit shorter, so that makes more sense. And we do have that crossover 2%. And 94, so there's also a 93. 93, probably somewhere here, I'm guesstimating. 94, 93, and then 92, probably somewhere here. And on the other side, we're starting from 93.5, so there's 93. most likely, well, we do have that crossed up here too, so keep that in mind. So when you're doing calculation, this point you have to find out using that 2%. So I'm just gonna skip that. And 93 is most likely here and here. And there's no 92, okay? So after that, we just connect the dot. So 94, and then you get back to 94, and then it's gonna come up here, and then where's 94? 94 is on the top of this there. So it probably will look like that. And then 93. Oh, you can do that, or, oh yeah, why not? And then 3 and 92. That's it. Any question?
Oh, thank you.
Yeah. If there's anything unclear, you probably just ask me, because if I'm just going over them, it's probably not going to be as helpful. So that's the 2 pages that have like a definite solution. And the 3rd page, you just have to understand these 2 pages on the front. So the 1st and 2nd page, you need to understand it so that you can design your own RAM. So the 3rd page, you really just have to do it on your own. So the 3rd page, what you want to do is find out how long your RAM has to be, and then understand that where you want to put your walkway. So you can put it here, you can put it here, you can put it here, it doesn't really matter. And for the RAM, you can do something like this, and usually that will work. And some people do it like this and connect back to the walkway so it's not so separated, or it's something like that. So you're using the same entrance. So you just have to figure that out and keep redoing it, redrawing it until the numbers come out right. So this one is really, you have to do it on your own. This is like a test of your knowledge for the first 2 pages. Okay, so any other questions? Let me stop this recording.